Hello everyone. You could watch the previous video titled Workbook Orientation video on how to find these guided lecture notes, and I'll be showing you the solutions to the pencil problems so you could read through the key concepts and the examples on your own, and I'll just quickly show you the solutions to the pencil problems. So here we're asked to rate the ratio of 2.6 to 10 as a fraction in lowest terms. So 2 indicates division, and the numerator would be 2.6 and the denominator is 10. But notice that we have decimals mixed in with a fraction, and so to eliminate that we need to make the numerator and the denominator both whole numbers, and since the numerator is to the nearest tenth, we're going to multiply the numerator and the denominator by 10. Now what that does for us is, if we multiply across, 2.6 times 10 is 26, so that makes it a whole number. And then divided by 10 times 10 is 100. And then we could reduce that fraction. So I reduce, you could use your fraction calculator actually to reduce. You could just type in 26. Let me show you that real quick. You could type in 26, hit the fraction key. Hopefully you watched the fraction video. Type in 100, hit enter, and it reduces it for us. Or, of course, you should know how to do it the old-fashioned way. Common factors 2. So if I divide both numerator and denominator by 2, I get 13 over 50. Now, it's not always 10 that you're multiplying by. Notice that in the pencil problem, or in the previous example that is, we had to multiply by 100 because the decimal number with the most decimal places was 7.38, which is to the nearest hundredth. So that's why we multiplied by 100. Okay, moving on to the next page. We got example 2. You could read through that on your own. To the pencil problem. This as a fraction, just write 0.25. Really, it's $0.25, so 25 cents, over $0.70. First thing we could do is eliminate the units. So we eliminate the dollar symbol and just write 0.25 over 0.70. And now notice that we have to get rid of the decimals again. And notice that the largest place value is to the hundredths place, so therefore we're going to multiply by 100. And so we get 25 over 70, and we could reduce that. I'm going to pick 5. Maybe that's not the biggest one, but I'll find out momentarily. And I get 5 over 14, so yes, that was the greatest count. 5 was the greatest common factor. Okay, next we move on to unit rates and unit price. So you can read over the examples. And to the pencil problem, it says a computer's hard drive rotates at 7,200 revolutions per minute. I rate it as a unit rate in revolutions per second. So per means division, so we're going to write 7,200 revolutions. I'll just abbreviate that. Divided by or over 1 minute. Now, all you have to do here is a simple replacement. So nothing fancy. All you're going to do, because all you have to realize is that there is 60 seconds in 1 minute, And so therefore a simple replacement, recopy the 7200 revolutions and replace 1 minute by 60 seconds. And then use your calculator to do the division. 7200 divided by 60 is 120. So this gives us 120. You could write it as revolutions over seconds, or you can literally spell it out and write it as 120 revolutions, and even just use the word per second. Okay, so next concept is proportions. And to determine if a proportion is true or false, we use cross products. Just to bring your attention to the example real quick. Cross products, take the denominator of the second, crossed over the equals, multiplied by the numerator of the first, and the denominator of the first, crossed over, multiplied by the numerator of the second. And you can see we did that here. Here's our two cross products. If they are not equal, this proportion is false. And so let's see about ours. I'm first going to set this up. I'll rewrite it off to the side here. Okay, and take the cross products. So I've got 5 times 12 equaling 3 times 20. Notice I'm using the multiplication symbol as a dot rather than as an X, because we're going to be getting into algebra. So good practice to avoid X's multiplication. And use the multiplication dot. And we get 60 equals 60. Okay, that's a true proportion then, because that's a true statement. Alright, so here we start introducing variables and solving proportions. One thing to point out before we go through a solution here is when we write something like 13x, the 13, the number that's before the x, it's implied that it's multiplication, so there's really 13 times x, and the number 13 is called the coefficient. And the x is the variable. Okay, so probably a good idea to get used to the term coefficient, because when we solve a proportion, all we do is cross multiply and divide, and you just simply divide by the coefficient of the variable. So I think running through this example might be helpful. We first cross multiply. It's 25 times x. You always want to write the coefficient first, so 25x, not x25. And then, so this is cross multiply. And then the second step is just divide. And you always just divide by the coefficient of the variables. So, as you might say, the number in front of the letter. So divide by the 25, use your calculator, we get a nice pretty answer. Now the variable x, a, b, n, whatever letter is used, can be anywhere in this proportion. So I'm going to recopy this proportion. 7 over 20 equals x over 100. Okay, do the cross multiplication. So that's 7 times 100 equaling, okay, I'll show it formally here, 20 times x. See, I don't need the times symbol in between there. And you don't really have to write that line. You could just take out your calculator, do 7 times 100, which is 700, and then equaling, and again, you don't need the multiplication symbol in between the 20 and the x, that's understood. So equaling 20x. And At that point, we need to divide, so we're just a two-step process, cross multiply and divide. And we always divide by the coefficient of x, or the number in front of the letter. So here, we're going to divide by 20. So I like to rewrite it, 20x over 20. Never write the x down here, you're only dividing by the number in front of the x. Then you do the same thing to this side. Notice formally how what happens is these 20's cancel. It gives us 1x over 1, or 1x, or just simply x. And that's why we're doing it, because we want to solve for x. And then 700 divided by 20 is, I believe it's 35. Okay, so then we get to the applications involving proportions. And the key to these problems is to what I call, I use the term here, as you can see in the key concept, should be mentioned, align the units. Okay? What that means, for example, is whenever you read a problem that involves proportions, it's a word problem, it's going to give you a primary ratio, or what we call the full ratio, and then it's going to give you a part of the other ratio, because a proportion is just equating two ratios. So here the primary or full ratio was 42 hits in 112 attempts. So we wrote that. What we mean by align the units is when you make your proportions here, we're setting it equal to, you want the units to be the same in the numerator and the denominator. So if we have hits over attempts, and we're given 105 hits, then that 105 hits has to align with the 42 hits. So that goes in the numerator. And then we can call the unknown x. Again, you could use any letter that you like, but x is typically what's used. I like to always associate the units and to set up the problem, and then it's just dropping the units, and then you go through the cross multiplication process. So cross multiply, as we've shown, and divide. So it's a two-step process again. And you could summarize it with a nice college-like sentence like we have. So sometimes you got to be careful with the wording. This one says a recent survey found that 9 out of 15 men are clinically overweight. So, and then it says if 60 men are in the study, how many were clinically if 60 men in this study were clinically overweight, how many men were in the study? Excuse me. So, you've got to realize that we're talking about 9 were overweight out of 15 that were in the study. I'll call it total. And we make our proportion, so we set it equal to, we want to align the units. This tells us 60 men were overweight. So the 60 has to go with the overweight people in the numerator. So 60 were overweight, and let me just call it X. Continue with total. Okay, so then once that's set up, you just drop the units. 9 over 15 is 60 over X. Cross multiply, 9x equals, I'll just do this on the calculator, 15 times 60 is 900, and then we divide by 9, coefficient of x. I always show an extra step for this division. I know a lot of you are just going to jump right in there, for example, and once you see 9x equals 900, it's okay to do this if you're confident and you're proficient enough. Just jump right in here and divide by 9, so you know, I showed an extra step, but no matter how you do it, you get x equals 100. And it is a word problem, so we could say 100 men were in the study. Okay, so aligning units is the key. And here's pencil problem 7. There's another example for you to consider. And it's a two-part example. Notice how, and just comment on the example quickly here. After we solve the proportion, we get 10.5, and that was 10.5 miles. And we wanted to convert it to feet. And notice that they gave us the conversion up here. The conversion factor was 5,280 feet is 1 mile. So when you have to convert something, we'll always give you the conversion factor, and all you need to do is multiply. So if there's 10.5 miles and there's 5,280 feet in every 1 mile, we just multiply 10.5 by the 5,280, and that would give us our answer in feet. So similarly, when we solve this problem, we'll have a conversion at the end. But to begin with, it says when making breakfast for 40 people, it's recommended to have 6 gallons of milk. Okay, so our full ratio, or our primary ratio, is 40 people over, I'll just say 6 gallons, and that's going to equal, okay, see the thing is, you don't even need to really think. All you need to do is fill in the units. You want people on top and gallons on the bottom, because they have to be aligned. And there's 200 people, so that goes in the numerator. Call it X gallons. Drop the units, 40 over 6 equals 200 over X. Cross multiply, 40X is 1200, and then divide. Always divide by the number in front of the X, its coefficient, and we get 30. So that would be 30 gallons of milk. But then it says how many cups, and 1 gallon is equal to 16 cups. So X is also equal to 30 times 16. Now we just multiply by whatever the conversion factor is. And 30 times is 480, and that would be cups of milk. Okay, so remember the pencil problems are a mirror image of the ones that are on the take-home quiz, either the example or the pencil problem. Excuse me. So feel free to use the notes as a guide when you do the take-home quiz. I recommend you do the take-home quiz at least once without the notes, and then try the actual quiz, where you only get 1 attempt. So take-home quizzes, infinite number of attempts, and actual quiz, 1 attempt. So hopefully you find these videos helpful.